The length of Polo's lunch break follows a normal distribution with mean meal and standard deviation 5 minutes. On one day in four, on average, his lunch break lasts for more than 52 minutes. Find the value of meal. Okay. So on 1 out of 4 days means that probability is 1 by 4. And his lunch break lasts more than 52 minutes. So we can write probability x is greater than 52 is equals to 1 by 4. We will standardize this and change x to z. When we standardize, we subtract mu and divide with the standard deviation, which is 5. Okay. Now, this will be written as 1 minus 5. 52 minus mu upon 5 is equals to 0.25, which means 52 minus mu upon 5 is equals to 0.75. Now we'll find the z-score corresponding to 0.75. That can be directly found from the table below the normal distribution table where some critical values are given. So we're told that when probability is 0.75, the z-score is 0.674. So we'll directly read that from here. So equals to 0.674. 52 minus mu upon 5. Okay, now we'll find the value of mu from here. 0.645, 0.674, sorry, times 5, and then 52 minus answer. That gives us 48.63. And in three significant figures, this is mu equals 48.6. Why did we round it off to three significant figures when this answer is exact? Because this is actually not an exact answer, because all these probabilities are actually estimates. They're not the exact probabilities. So that's why mu is also an estimate. So we round it off to 48.6. I'm sorry if you can hear my children in the background. Part 2. Find the probability that Polo's lunch break lasts for between 40 to 46 minutes on every one of the next 4 days. Yes, so we'll start with 40 less than x less than 46. Then we'll standardize 40 minus mu, which was 48.63, divided by standard deviation, which was 5. Same with 46. This would give, this supposed to be z in the middle. This would give us minus 1.726 and minus 0.526. Okay. We would round these off to 3 dp in case they're bigger, because these scores only need to go till 3 decimal places. Okay, now we'll use the rule of normal distribution that if we have negative values on both sides of z, then this is equals to phi a minus phi b. So we'll write phi 1.726 minus phi 0.526. Okay, this would give us 0.9578 from the probability distribution table, from the normal distribution table here. And the other one would give us 0.7005. Let me just quickly confirm if these are true or not. 1.726 would give us 1.7. 2 is here, so this is the probability, and 6 is here. So we add a 5 in the end. So 0.9573 plus 0.0005 gives us 0.9578. That one was correct. And for the other one, we have to check the z-score of 0.526. Okay. So 0.5 is here, 2 is here, and 6 is 20 in the end. It's 0.6985 plus 0.0020, which gives us 0.005. So both of these are correct. Subtract 0.9578 minus 0.7005, which gives us 0.2573. Okay, but the question says, find the probability that Polo's lunch breaks last for between 40 to 46 minutes on every one of the next 4 days. This is only for one day. So for the next 4 days, we're going to give it a power of 4. To answer power 4 is 0.00438828. So in three significant figures, we're getting 0.00438. State two conditions. Sorry. So the next question is, state two conditions which must be satisfied for a situation to be modeled by a binomial distribution. Okay, so we have studied 4 such conditions, of which you can mention any 2. What were these 4 conditions? That there are a fixed finite number of trials. The outcomes of each trial is independent of the outcome of the other trials. There are exactly 2 outcomes of each trial, success or failure, and the probability of success is constant. So you may mention any 2 out of these 4. This is the answer for part 1. In a certain village, 28% of the cars are made by Ford. 14 cars are chosen randomly in this village. Find the probability that fewer than 4 cars are made by Ford. Okay, this is binomial distribution. So fewer than 4 means maybe 0 cars are made by Ford, or 1 out of the 14 cars is made by Ford, or 2 out of the 14 cars are made by Ford, or 3 out of the 14 cars are made by Ford. Okay, so the formula for binomial distribution is 14C0 in the first case, probability of success, which is 0.28, power 0, probability of failure, which will be 1 minus 0.28, which is 0.72, power 14, plus 14C1, success power 1, failure power 13. Similarly, 14C2, success power 2, failure power 12. And 14C3, success power 3, failure power 11. Okay. Add all of this in the calculator and you should get 0.4187 rounded to 0.419 in 3 significant figures. Part 3. A random sample of 50 cars is chosen in the village is taken. Estimate using normal approximation, find the probability that more than 18 cars are made by Ford. Okay, so in this case, we have to change binomial distribution into normal distribution. For that, we first apply continuity correction. It says probability that more than 18 cars are made by Ford. So probability X is greater than 18. Now, since this is greater than, we apply continuity correction and change this into 18.5. Please remember, if this was greater than and equals to, we would actually change it into its lower bound, which would be 17.5. And if it were just less than, even then we would change it into lower bound. But if it were less than and equals to, then we'll change it into upper bound, which would be 18.5. Okay. So probability X is greater than 18.5. Now we will standardize it. So probability Z is greater than 18.5 minus mu upon sigma. So we subtract the mean, divide the standard deviation to standardize this. Okay, now how do we find mu? Mu is the same mu we find in binomial distribution, which is n times p. N is for 50 cars, and probability of success is 0.28, which gives us 14. And standard deviation is equals to square root of NPQ. So square root of N is 50, P is 0.28, and Q is 0.72. Okay. What is this equals to? 50 into 0.28 into 0.72 is equals to 10.08. So square root of 10.08. Okay. So I'm changing standard deviation into square root of 10.08 and mean into 40. Okay. So this would become probability Z is greater than 18.5 minus 14 divided by square root of 10.08, which gives us 1.41736, but we only need to go till three decimal places for z-score, so 1.417. Okay, now go to the table and read the probability corresponding to the z-score of 1.417, but before that we'll have to rewrite this as 1 minus phi 1.417. So 1 minus, what's the probability corresponding to 1.417? It will be 0.9217. So read this from the table, you'll get 0.9217. Subtract 1 from it, and you would get 0.0783 as the final answer. It is known that on average, 2 people in 5 in a certain country are overweight. A random sample of 400 people is chosen using a suitable approximation. Find the probability that fewer than 165 people in the sample are overweight. Using a suitable approximation means you have to change binomial distribution into normal distribution. For that, the first thing we do is continuity correction. So probability, we have to find that fewer than 165 people in the sample are overweight. So X is less than 165. Apply continuity correction. Since this is less than, we'll change it into its lower bound, which is 164.5. Remember, if it were less than and equals to, we would actually change it into its upper bound, which would have been 165.5. Okay, now we standardize by subtracting the mean and dividing with the standard deviation. Now the mean is the same mean of binomial distribution, which is n times b. N here is 400, and probability of success would be, it says it is known on average 2 out of 5 people are overweight. So probability of success or of being overweight is 2 by 5. So this gives us 400 into 2 divided by 5, which is 160. For standard deviation, we use the formula square root of npq or np 1 minus p. So square root of n, which is 400, p, which is 2 by 5, and 1 minus p would be 3 by 5. This gives us square root of 96. So I'm going to replace the mu by 160 and the standard deviation by square root of 96. Okay, this would give us C is less than 0.4592, but z-scores are needed till 3 decimal places only, so 0.459. Now read the probability corresponding to the z-score from the normal distribution table, 0.459. Okay, so 0.4 is here, 5 is here, so this is the probability, but 9 is here, so we have to add 3 to the last two digits. Okay. This would give us, this becomes 8676, so 0.6768. 0.6768. Remember, these probabilities are estimates and not exact probabilities, so we further round it off to 3 significant figures as our final answer. Tire pressure on a certain type of car independently follows a normal distribution with mean 1.9 bars and standard deviation 0.15 bars. Find the probability that all 4 tires on a car of this type have pressure between 1.82 bars and 1.92 bars. Okay. So we have to find the probability that the pressure is between 1.82 to 1.92 bars. Okay. Now we standardize by subtracting each of these with the mean dividing with the standard deviation. So the x can be rewritten as z, indicating normal distribution. So 1.82 minus 1.9 divided by 0.15 and 1.92 minus 1.9 divided by 0.15, which gives us, the left side becomes negative 0.533333 recurring, but we just need 3 decimal places. So, okay, let's just write the 3 recurring dot here, and then the next step we'll write 3 decimal places. And this side becomes 0.133333. Okay, so now rounding it to 3 decimal places. Remember, z-score only needs to go till 3 decimal places. Okay. Now we have one side negative, one side positive. For this, we will apply this rule that if we have negative a to b, then this can be rewritten as phi a plus phi b minus 1. So we can add the two probabilities of the two z-scores and then subtract it with negative from 1. Okay, so for 0.533, let's see what is the probability. 0.533 is the z-score, so 0.5 is here, 3 is here, so this is the probability. There's another 3, so we add 1 0 to the end, so this will become 0.7029. So we have 0.7029. Similarly, you read the probability for the z-score 0.133, and this will come out to be 0.5529. Subtract 1, we'll get 0.25. Let me just calculate this. 0.7029 plus 0.5529 minus 1 gives us 0.2558. Okay, now we will give it a power 4 because it says find the probability that all 4 tires on a car of this type have pressure between 1.82 to 1.92. We just found for one tire. So if we need to calculate this for all 4 tires, we'll have to give it a power of 4. So answer power 4 gives us 0.00428815, rounds to 0.00428. Part 2. Safety regulations state that pressure must be between 1.9 minus B bars and 1.9 plus B bars. It is known that 80% of the cars are within these safety limitations. Find the safety limitations. Okay, so safety limitations are 1.9 minus B bars to 1.9 plus B bars. To standardize, we will have to subtract the mean, divide the standard deviation. So minus 1.9 divided by 0.15, x becomes z. Again on this side, subtract the mean, divide the standard deviation. So we get minus b upon 0.15 and b upon 0.15. Okay. So when we have again negative on one side, positive on one side, we add their probabilities and then subtract the answer from negative 1. And we're told that this is actually equals to 80%, so 0.8, equated to 0.8. So we get 2 phi b upon 0.15 equals to 0.9, sorry, 1.9, and then we divide, sorry, 1.8. Divide it with 2, we get 0.9. So now we have to find what z-score gives us a probability of 0.9. You'll find 0.9 at the bottom of the table where critical values are mentioned. So when the probability is 0.9, the z-score is 1.282. So the z-score is 1.282. This is the z-score in this case, b upon 0.15, okay, which gives us b equals 0.1923. Okay, the question was find the safety limits. Safety limits were these. These were the safety limits. So we subtract b from 1.9 and we add the b from to 1.9. Okay, so that would give us 1.9 minus b, which is 1.7077, and 1.9 plus b, which will give us 2.09213. And when we round it off to three significant figures, we're getting 1.708 and 2.09. In fact, this would become 1.71 in three significant figures. In test on a new type of light bulb, it was found that the time they lasted followed a normal distribution with standard deviation of 40.6 hours. 10% lasted longer than 530 hours. Find the mean lifetime. Give your answer correct to the nearest hour. Okay. So we'll start with probability. X is greater than 5,130 is 10%, so 0.1. Standardize, so we'll subtract the mean, divide the standard deviation, equals to 0.1. Now, this have to be rewritten as 1 minus phi 5130 minus mu upon 40.6 equals 0.1, which gives us 0.9 equals 5130 minus mu upon 40.6. Now, find the z-score for which the probability is 0.9. That can be found right here at the bottom of the table. When probability is 0.9, the z-score is 1.282. So 1.282 equals to 5130 minus mean upon 40.6. Solve this to find the value of mu, and you would get 5077.9508, and correct to the nearest integer, it will be 5078. Part 2, find the probability that a light bulb fails to last for 5000 hours. That means we'll have to find the probability that it lasts for less than 5000 hours. So probability Z is less than, standardize this, subtract the mean, which is 5077.9508, divide the standard deviation, which is 40.6. This gives us negative 1.927, no, negative 1.9209. Now the z-score only need to go till 3 decimal places, so 1.921. Now we're going to fix this and write it as 1 minus 5, 1.921. Read the probability corresponding to the z-score of 1.921. That would be 1.9 is here, 2 is here. So this is the probability. There's a 1 in the end, so we add a 1 in the end. So 0.9727. So 0.9727, and subtract from 1, we get 0.0273. That's part 2. Part 3. A hospital buys 600 of these light bulbs. Use a suitable approximation to find the probability that fewer than 65 light bulbs will last longer than 5130 hours. Okay, so fewer than 65. Okay, this is a question of converting binomial distribution to normal distribution. So for that, we first apply continuity correction, change this into its lower bound, 64.5. Then we standardize 64.5 minus mean, which was 5077.9508, divided by the standard deviation, which was 40.6, which would give us C is less than. Oh, no, 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 no. Mean and standard deviation is now going to be the mean of binomial distribution, and standard deviation will be the standard deviation of binomial distribution. Sorry. Okay, so mean is equals to NP in binomial distribution, and here is 600. And P is the probability of success, which is the bulb will last longer than 530 hours, so that would 0.1. So P is 0.1. This will give us 60. So mean is 60. So we'll subtract 60. And for standard deviation, we're going to use the formula. Standard deviation is equals to square root of NPQ. N is 600. P is 0.1. So then Q, which is failure, would be 0.9. Okay. This would give us square root of 54. Let's calculate this. 64.5 minus 60 divided by under root of 54 gives us 0.6123. Okay. This becomes in 3 decimal places 612. Read the probability corresponding to 0.612, which will come out to be 0.7298. And in 3 significant figures, it's going to be 0.730.